If you're evaluating a trig expression, then you need to be really careful that you only use proven identities. So here we've got a situation where we have to evaluate. Now, what does evaluate mean? It means find the answer. So we don't want to just fiddle with this and make it look different. We want to come out with an actual number for an answer, a value. Now we need to evaluate sine squared 56 degrees plus sine squared 34 degrees without using a calculator, and we have to give reasons. Now this is a 2-mark question, so let's look at what the 2 marks are going to be for. Now I'm going to start by actually showing you what not to do and explaining why. If we have, another way of writing this, don't forget, would be to say we're taking all of 56 squared. Okay, this is the neater and more normal way to write it, but let's just think this through, why this isn't going to work. Right. Now if we're adding the square of two things, and those two things are different, it's a bit like saying x squared plus y squared, isn't it? You can't take parts of that x and parts of that y and add them together. This is a different thing and this is a different thing, and they've been squared and then added, and this is as good as it gets. And yet it's sort of tempting here, because you might notice that 56 and 34 add up to 90. A lot of people doing this question will be really tempted to say that that equals the sine of 90 all squared. Okay? Now, the sine of 90 is 1, and if you square 1, you get 1. Now, the problem with this is that the answer actually is 1. And so if you do it this method, which is incorrect, you get the right answer and you feel all satisfied like you've reached the right answer, and you can put this into the calculator and see that it does come to 1. Now, they've asked you to do it without a calculator for a reason. If you found it by using the calculator, they don't want that. And if you've done it by coming to this first, you haven't actually got a good reason that that makes sense, do you? You can't pick and choose bits out of what's being squared and add them together and assume it will all work out okay. In this case, it's a coincidence that it does because they've been squared. But let me give you another example. If things weren't squared, can you take, say, the sine of 20, add it to the sine of 70? Will that give you the sine of 90? No, you haven't learnt anything about being able to add those to make that. All right, so the fact that it does work when you square them is by the by. It's not the way we want to go. But you have noticed that 56 and 34 add up to 90, and that's a great clue. We do need to use that. Now, write down the identity that you're thinking of. Sometimes that will help you to write your first line. Now, I know that the sine of theta, any angle, is the same as the cos of 90 minus that same angle. Okay? So that means I can switch between sine and cos whenever I like. I've just got to do this, swap those to make up for it. Okay? Now, these add to 90. So obviously 56 is 90 minus 34, isn't it? So I can use this identity to change one of these. I can change either one. I could either change this one and say sine of 56 is the same as cos of 34, and I can rewrite it and say that's cos of 34 all squared, and I'm just going to leave this one the same. Okay? And then this is my reason in brackets, so I'm giving reasons in brackets that explains what I've done and why I knew I could do it. Now looking at that, what have we got? Cos squared of some angle plus sine squared of the same angle. Well, think what you already know. You know that sine squared theta plus cos squared theta equals 1. That's a basic a Pythagorean identity. Now it doesn't matter what theta is, as long as those two angles are the same, when you add them together, the square of them, you get 1. So on the next line, you can get your 1, and here's your reason. Now it's a 2-mark question. You get a mark for each line with its reason, and without its reason you won't get the mark. If you just write 1 with no reasons and no working, you'll get 0. So the reasons are really, really important. Now the other thing you could have done here, of course, let's use another colour, you could have kept this one the same and said that's sine squared 56 and changed this one to cos. Now if you're changing to cos, you've got to do 90 minus 34, which of course is 56. And this plus this, it also equals 1, and you'd have those two lines with the exact same two reasons.